we are going to look at how to use an example to find the square root of a given SAT. More specifically, a SAT that has two terms, a binomial. So let's consider the example. So this is the question. Find the positive square root of 10 plus 2 square root of 21. 10 plus 2 square root of 21. Good. So let's consider our solution here. We are saying that the square root of a SAT of the form of this form, right? The square root of that must be of the form square root of A plus square root of B. It must be of the form square root of A plus square root of B. Now, be very careful about the sign that is here, the positive sign that is here. If it were negative, then here is also as would have also been a negative sign. So take good note of that. Good. So when we take the square root of 10 plus 2 square root of 21, it is going to be of the form square root of A plus square root of B. Alright. Now, when we have this, our aim is going to be to try to remove the square root and then try to find the values of A and B. So you and I know that when we have something like this and we want to remove the square root, we square both sides. We take the square of what? Both sides. So our next step brings us to looking at how to find the values of A and B by squaring both sides. Now, we are going to assume that A is greater than B. We are going to assume that A is greater than what? B. Alright. So, squaring both sides, we are going to have square root of 10 plus 2 square root of 21 and then square it. So you have our square over here. And when we do that, we have to square the other side too and make it square root of A plus B all squared, which we have it over here. When we do that, the square here will take care of the square root over here. Right. So our next step will now give us 10 plus 2 square root of 21, and then we then have to expand this one. And you and I know that when we expand square root of A plus square root of B squared is the same as square root of A times square root of B. So we are going to expand by using the A to multiply the square root of A to multiply the square root of A, the square root of A again to multiply the square root of B. Then we use the square root of B to multiply this one, and use the square root of B to multiply this one too. Good. So this brings us to the next step where we have square root of A times square root of A will give us square root of A squared. Square root of A times square root of B will give us square root of AB. Square root of A times square root of B will give us square root of AB. And square root of B times square root of B will give us B squared. Now the square and the square root will take care of each other. The square and the square root will take care of each other, giving us A and giving us B. So our next step gives us 10 plus 2 square root of 21 is equals to A plus B, then plus square root of AB plus square root of AB will give us 2 square root of AB. We are adding the 2. Now, given this particular equation, we are going to take the terms that do not have a square root here, and then we equate them to the term which has no square root here. So you are going to have A plus B is equals to 10. And we set that as our equation 1. Now we are going to take what has the square root here and the term that has the square root here and the term that has the square root on the left hand side and compare them. And when we compare them, you realize that the a plus b, which is under the square root here, will be equals to the 2 to 1, which is under the square root here. So we have something a b is equals to 21, and we set that one as our equation 2. Now these become a simultaneous equation which we need to solve them together. So we can only solve this by using the substitution method. So first of all, we will take the square root of the first equation, equation 1, and make a the subject. Making a the subject means that letting a to stand alone at one side of the equal sign, whilst other terms stand at the other side. So in making a the subject, we arrive at our equation 3, which is a equals to 10 minus b. A equals to 10 minus b. Now we are now going to resubstitute that equation back into equation 2. So in equation 2, wherever we see a, we are going to fix 10 minus b. So that brings us to the next point. So substituting 10 minus b in place of a in equation 2, we'll get 10 minus b all in bracket times b equals to 21. Then we'll do expansion. So I have 10 times b and then 10b times b. So this brings us to 10 times b will give us 10b, and b times b will give us b squared. Now this brings us to quadratic equation because of the square here, quadratic equation in b. So what we need to do is to rearrange the equation. So rearranging it gives us b squared minus 10b plus 21 equals to 0. We can solve this quadratic equation by completing the squares, or by using the general quadratic formula, or by factoring the terms. So if we consider using factorization, then we are going to use the coefficient of the b square here, which is 1, and multiply by the constant here, which is 21. And when we do that, 1 times 21 gives us 21. So we're going to look for two factors of the 21, that when we multiply, we'll get the 21, but when we add, we'll get the coefficient of the b, which is the negative 10. Alright, so those two numbers are obviously going to be negative 3, which is here, and then negative 7, which is here. Now, negative 3 times negative 7 will give us 21, and negative 3 plus negative 7 will give us 10. So we are going to replace the negative 3 and the negative 7 with we'll replace the negative 10 with the negative 3 and the negative 7. So this gives us, so then have b squared minus 3b minus 7b, which gives us negative 10b. Then we have our 21 here. So we will then factor them 2 times and 2 by 2. So we group them and factor them. So when we group these ones and factor them, we'll bring the b is common, so b stays out. B will be left here, and then b out, 3 will be left here. Here 7 is common, so 7 goes out. Then b will be left here, and then when 7 goes into 21, we'll get 3 times, so it means 3 left here. realize that b minus 3 then b minus 3 are the same. So we take one of them as our factor, and then we will combine the b outside here, and then the negative 7 outside here too, to form another factor. So this brings us to the next step. So we have b minus 3 as one factor, then b minus 7 as another factor, equals to 0. So when we take b minus 3 and equate it to 0, we are going to get b equals to 3. And when we take b minus 7 equate it to 0, we arrive at b equals to 7. So b equals to 3, then b equals to 7. These are the values of b that satisfy the quadratic equation. Now, to find the values of a, we then have to substitute the a 3 in place of b into our equation 3, which is here. So in place of b, we'll substitute 3, and in place of b, we'll substitute 7, so that we'll get the values of a. So we then have, in substituting 3, we'll have a is equals to 10 minus 3, and that gives us what? A 7. And then in finding b, a again, by substituting b equals to 7, we'll get 10 minus 7, which gives us what? A 3. So therefore, when b is equals to 3, a is equals to what? When b is equals to 3, a is equals to 7. You see there? Yes. And when b is equals to 7, a is equals to what? 3. And then you have it there. Now, initially, we said that we are going to assume that a is greater than b. We are going to assume that a is greater than b. So if that assumption still holds, then we'll say that a will be the 7, which is the greater value, and b will be the 3, which is the what? The smaller value. Now, substituting them back into the initial equation, we'll say that then the positive square root of 10 plus 2 square root of 21 is equals to square root of 7, which represents the a, plus square root of 3, which represents the what? The b. And this brings us to the end of this problem. I hope you have learned something new, and I'll urge that you will subscribe. Thank you very much, and see you next time. Bye.